Okay, today I want to talk about section 6.8 and the 7.8. Maybe I need to spend 1 hour 30 minutes for explaining two sections today. The section 6.8, indeterminate forms, L'Hopital's rule, and relative rate of growth. The first is I'll just give some outline. In this section, I want to talk about 4 kinds of limit problems. The first one, limit f of x over g of x as x approaches a. Second one, limit of f of x times g of x as x value approaches a. Third one, limit f of x minus g of x as x approaches a. Last one, limit f of x to the g of x as x value approaches a. If you unmute your sounds, okay, thank you. So what are the indeterminate forms? So we have 4 kind of things: indeterminate quotients, indeterminate products, indeterminate difference, indeterminate powers. We have these 4 kind of problems. So how can we find the limit of an indeterminate form? Usually we can use 3 methods in this section. First one, algebraic method. Second one, L'Hopital's rule. Third one, relative rate of growth. We think about this kind of things. Okay, next we think about indeterminate quotients. Consider type 0 of 0 and infinity over infinity. So type 0, 0. Here, limit x value approaches 0. The function is x over x. So this is exactly 0 of 0 form because you plug 0 into bottom one and top one exactly the 0 of 0 form. So we have this type. How can you solve? So like this. Cross out x. We have 1 over 1. Limit of 1 is, what's it like limit of 1? What is the answer? Limit of 1? Could you write your answer? Okay, the limit of 1 is, yes, same number, 1. So we have it. The limit exists. Type 0 of 0, second problem, limit of x over x squared as x value approaches 0. This is exactly 0 of 0 form. You plug 0 into top and the bottom one, exactly the 0 of 0 form. So how can you solve? This is the idea. You have to cross out 1x, limit of 1 of x. So what is limit of 1 of x as x value approaches 0 from the right? Yeah, Peter said like infinity, is right? The infinity? Yeah, orderly said infinity, yes. You can draw graph. The f of x equals the 1 of x is graph is like this. X value approaches 0 from the right. What happens? 1 of x? 1 of x is going to positive infinity. So we have it. Limit does not exist. Next one, type infinity over infinity. Limit x over x as x value approaches infinity. This is infinity over infinity form. Same idea. You can cross out common factor x, limit of 1. The limit of 1 is 1. The limit exists. The similar one, limit x squared of x as x approaches infinity. So you just cross out common factor 1x, limit of x. X value approaching infinity, x is going to positive infinity, limit does not exist. What's that? The limit may or may not exist in type of 0 over 0 and infinity over infinity. So we call this kind of types indeterminate form of type 0 over 0 or infinity over infinity. This is like idea. We have two types. How can you find the limit of an indeterminate quotient? So here, you plug 1 into top one and bottom one, what happens? 1 square minus 1 over 2 times 1 square minus 1 minus 1. Top one is 0. Bottom one is 2 minus 2 is also 0. Exactly indeterminate quotient type 0 over 0. So how can you solve? I want to use algebraic method. You have to factor top one and bottom one. Top one is x minus 1 times x plus 1. Bottom one is x minus 1 times 2x plus 1. Next, you cross out x minus 1, so we have it. You plug 1 into x, 1 plus 1 over 2 times 1 plus 1. Answer is 2/3. Second problem. X value approaches infinity. The function is x squared minus 1 over 2x squared minus x minus 1. What's that? You plug infinity into top one and bottom one. What happens? Exactly infinity over infinity form. How can you solve this problem? So we use this side here. You divide top one and bottom by highest power term in the denominator, x squared. The next, you have to distribute 1 over x squared. Is right? You distribute 1 over x squared. Here and here. What happens? X squared minus 1 over x squared is 1. Second one, 1 times 1 over x squared is 1 over x squared. You can distribute 1 over x squared to the first, second, third one. The first one, x squared is crossed out, only 2. Second one, x is crossed out, 1 over x. Third one, 1 times 1 over x squared is 1 over x squared. So we have this one. The next, we have this one. Because x value approaches infinity, 1 over x squared is going to 0. 1 over x is going to 0. 1 over x squared is going to 0. This is the idea. It is possible to find the above limits by algebraic method. So here, it is difficult to find the limit by using algebraic method. This one is the same. The algebraic method is impossible. How can you solve this kind of problems? So we have one good method, today title, that we use L'Hopital. What's it like L'Hopital? Here. The L'Hopital rule is like this. Suppose f and g are differentiable and g prime of x is not equal to 0 on an open interval I that contains a. Suppose that limit of f of x as x approaches a equal to 0, limit of g of x as x value approaches a equal to 0, or limit of f of x as x value approaches a equal to plus minus infinity. The limit of g of x as x value approaches a is plus minus infinity. So what does it mean? We have two types, 0 over 0 form or infinity over infinity form. How can you solve limit of f of x over g of x for these two types? This is the rule. Limit of f prime of x over g prime of x as x value approaches a. So that's it. This is called L'Hopital. If the limit on the right side always exists, or infinity or minus infinity, one more, you can replace x approaches a by x value approaches a from the right, x value approaches from the left, x value approaches infinity, x value approaching minus infinity, it doesn't matter. So we have same result. So we call L'Hopital rule. So we just only apply this rule to our previous example, limit of ln of x over x minus 1. So what's that? The first one here, what's that? You plug 1 into x. So what happens? ln of 1 over 1 minus, this is ln of 1 over 1 minus 1. So ln of 1 is 0. 1 minus 1 is 0. Exactly type 0 of 0. How can solve? We use here, L'Hopital rule. L'Hopital rule. So you can take a derivative top and bottom. So ln of x prime is, what is ln of x prime? Could you write your answer? What is ln of x prime? This one? Yeah, thank you, all of guys. 1 of x. So x minus 1 prime is 1. So we have this result. So simplify, limit of 1 of x over 1 is just the limit of 1 of x. You plug 1 into x, 1 of 1. Answer is 1. So this is possible by using L'Hopital rule. Second example, limit of ln of x over x minus 1. X value approaches infinity. X value approaches infinity. What happens? Top is going to positive infinity. The infinity minus 1 approaches infinity. So what does it mean? We have second type. Infinity over infinity. So we use L'Hopital rule. So like this, we have the same answer. Limit 1 of x over 1, x value approaching infinity. Limit of 1 of x as x value approaching infinity. So 1 over infinity is, what is the answer? The last one. Okay. The two guys, Peter and the Connor says the 0. Yes, this is going to 0. This is the answer. So that's it. This is the idea. The next problem. Here, you plug 0 into top one and bottom one. Top one is tangent of 0 minus 0 over 0 cube. Tangent of 0 is 0. The 0 cube is 0. Exactly 0 of 0. We have this type. I want to use L'Hopital rule. So like this. L'Hopital rule. So we can take a derivative. Tangent of x prime is secant square. X prime equals 1. X cube prime is 3x squared. You can plug 0 into top one and bottom one. We have secant square of 0 minus 1 over 3 times 0 squared. What is secant of 0? What is secant of 0? Okay, this answer is, 1, because the secant of 0 is same to 1 over cosine of 0. Cosine of 0 is 1. Answer is 1. So we have top one is 1 square minus 1 over 0. Answer is 0 of 0 form. The 0 of 0 form, again, what's that? We use L'Hopital rule again. So like this. What is secant square prime? What's that? What's the top one? What is secant square of x prime? What's that? Do you know answer? What is secant square of x prime? So could you write your answer on board? 2 secant square times tangent. So what do you think? Is right? I can check. You can use chain rule first. The secant square prime is 2 times secant of x times inner function secant of x prime. So we have 2 times secant of x times secant x times tangent x. We have it like this. So we have this one. You can combine secant times secant, like secant square. The next, you plug 0 into here. What happens? Secant of 0 is 1, is right? This value is 2 times 1. So we have 2 times 1 over 6. You plug 0 into here. What's the tangent of 0? Tangent of 0 is, yep, right, 0 over 0. Yes, 0 of 0 form. So we choose like a non-zero. To secant square of x over 6 is like a non-zero. You have to take out. Right? When you take out non-zero part. So secant 0 is, this is exactly 1. You can change 1. The 1/3. 2 is crossed out. Change 3. This is going to 1. 1/3. Tangent of x over x is 0 over 0 form again. You have to use L'Hopital's rule again. So tangent prime is secant square, x prime is 1. You plug 0 into x, secant of 0 is 1. We have 1/3 secant square of 0, 1 times 3 times 1 over 3 times 1 equals 1/3. So this is idea. The next thing, sine of x over 1 minus cosine of x. We can try L'Hopital's rule. Sine prime is cosine. Cosine prime is negative sine. So we have it. The minus sign is a positive sign. The next, what is the answer? So I want to use this one. We can draw graph of cosine. So like this. This value is pi. This is pi. This one is -1. This function is cosine of x. Yeah, you're right. -1 over 0, right? So what's it like a sine function? Sine function is like this. This is like pi. This is sine of x. So what's it like this one? X value approaches pi from the left. You plug pi into cosine and sine. Cosine of pi over sine of pi. What's that? Cosine of pi is -1. Sine pi is like 0. The next one. X value approaches pi from the left. So X value approaches pi from the left. Sine function is above x-axis, positive. This is like sine function is positive. Cosine is like negative. What is the answer? Answer is like -infinity. So we have -infinity. This is the answer. This is right. This answer is right. What do you think? This is right? -infinity? No. Yes. Unfortunately, no. Why? Here. X value approach pi from the left. What happens? Sine x over 1 minus cosine x. You plug pi into top one and bottom one. You can plug pi into here. Sine pi is 0. Plug pi into here, the -1. Exactly 0 over 2. The 0 over 2 is not indeterminate form. What does it mean? Don't use L'Hopital's rule. This is very important. So how can you solve? Just plug pi. 0 over 2 is 0. That's it. This is answer. Don't use L'Hopital's rule because this is not indeterminate form. The next one. The limit of f of x over g of x is infinity over infinity. The one important thing is x value approaches positive infinity. How can we solve? So we have another method. Yes, we can use L'Hopital's rule, so we can solve. We have another method is relative rate of growth. What is like a relative rate of growth? I'm going to explain to you here. What L'Hopital's rule? The function f of x grows faster than function g of x as x value approaches positive infinity. Limit f of x over g of x as x value approaches infinity equal to infinity, or opposite one, the limit of g of x over f of x as x value approaches infinity equal to 0. So this is like a definition. Another one, we also say that g of x grows slower than f of x as x value approaches positive infinity. This is the definition. We can use this notation. Can use this notation. This is like answer. Next one. F of x and g of x grow at the same rate as x value approaches infinity. Limit f of x, g of x is m. It's not equal to 0 and finite number. This is like a definition. Note, we use this notation. We can just bridge. G of x and f of x grow at the same rate. It's like a notation. So here, I'm gonna take derivative top and bottom by using L'Hopital's rule because this is infinity over infinity form. This is the reason. The ln of x prime is 1 over x. ln of x prime is ln of x prime over ln of x. The ln of x prime is 1 over x again. We have 1 over x over 1 over x times ln of x. You can simplify. X is crossed out, such that ln of x. Answer is infinity. So what does it mean? Top one is growing faster than bottom one. The top one is growing faster than bottom one. Another one, limit of f of x, ln of x over x as x value approaches infinity. So we have infinity over infinity form. So we use L'Hopital's rule. The 1 over x over 1, just 1 over x and 0. What does it mean? The bottom one is growing faster than top one. The bottom one is the growing faster than top one. Limit x squared over e to the x. Take the derivative again. 2x over e to the x. This is infinity over infinity form again. Use L'Hopital's rule again. So we have 2x prime over e to the x prime, exactly 2 over e to the x. 0. So what does it mean? The bottom one is growing faster than top one. This is the answer. So like this. So we can combine this whole result. We have one good table for relative rate of growth. This one. So what does it mean? So ln of x to the alpha is greater than or equal. Sorry, this is like the slower than ln of x to the beta. ln of x to the beta is slower than x to the p. X to the p grows slower than x to the q. X to the q is slower than a to the x. A to the x is slower than b to the x. The b to the x is slower than x to the x. So one example here. Limit x value approaches infinity. ln of x to the 100 over square root of x. What is answer? What is answer? Could you write answer of this question? What is answer? Do you have any idea? Answer of this question? Do you have any idea? So I can use table here. ln of x to the 100 is here. ln of x to the power 100. The root x is, what's it like root x? X to the 1/2. You can compare. What's that? X to 1/2 is growing faster than ln of x to 100. What does it mean? The bottom one is growing faster than top one. Answer is 0. That's it. So one more. Limit x value approaches infinity. So we have x to the 100 over ln of x to the 1000. What is the answer? What is the answer? Infinity. The p said infinity. Is right? Infinity. Infinity. Yes, you can use table. Thank you for your answer. So here, x to the 100 is this one. Here, ln of x to the 1000 is here. So we have this inequality. X to the 100 is growing faster than ln of x to the 1000. Top one is growing faster than bottom one. Answer is infinity. This is the whole idea by using table. So I want to give more examples here. What do you think? What is the answer? So what is the answer of this problem? So what is the answer? You think about it. What is the answer? Infinity. Answer is infinity. 0. 0. This is the idea. Answer is 0. You have to ignore constant. X value approaching infinity. What does it mean? Top one is going to infinity. Bottom one is going to infinity. Exactly. Infinity over infinity form. I want to use this table. How can you use? Here, you have to ignore 10. You can check top one. Top one has here ln of x to the 100 is here. So you have to ignore coefficient. It doesn't matter. ln of x to the power 1, ln of x is here. Which one is growing faster? ln of x is growing faster. So you have to ignore slow. The root x plus 1, ignore constant. So we have limit x value approaches infinity. Top one has ln of x. Bottom one has square root of x is x to the 1 over 2. Here, ln of x is here. X to the 1 over 2 is right hand side. X to the 1 over 2 is growing faster than ln of x. Answer is 0. That's it. This is the idea by using this table. So next one. What is answer? Oh, why do you cross out ln of x? Here, you can compare. Only numerator. This one and this one and this one. 10 is like a constant function. X value approach infinity. 10 is going to just 10. It's not going to infinity. Ignore. So you can check which one is growing faster. ln of x to 100, only ln of x. Here we can compare ln of x to the 100, the ln of x to the power 1. ln of x to the 1 is growing faster than ln of x, ignore slow one. This is like the idea. Only choose the fastest one on the top and bottom one. This is idea. You're right. Only choose fastest one on the top and the bottom one. Yeah. So bottom one. What do you think? What is answer? So what is answer? Infinity? Infinity? You think infinity? Yes, infinity. Because here, you can change it. We have 4 to the 2x to the change it. 4 square to the only power x. Exactly 16 to the x. Right? You can change it. 16 to the x, but change. But next, you have to use table. Here, what's that? 9 to the x here. The 16 to the power x. The 16 to the power x is growing faster than 9 to the x. Ignore slow one, ignore constant. The 10 to the x is here. We have 10 to the x here. X to 1000 is here. ln of x is here. ln of x to the power 100. You can use this inequality. What happens? 10 to the x is growing faster than any other things. Ignore slow one, ignore constant. So we have limit x value approaches infinity, 16 to the power x over 10 to the power x. What is the answer? Answer is infinity, because the 16 to the x is growing faster than 10 to the x. This is idea. We have it. The last one. What is the answer? What is the answer? Answer is, do you know answer of this question? So what do you think? So far, don't use table, because we don't have ln of x to 5. Only x to 5 and the 1. X value approaching infinity. X to the 5 is going to infinity. Once it's just constant, ignore constant. What does it mean? Just limit x value approaches infinity, ln of x to the 5 over ln of x. Next, ln of x to 5 is 5 times ln of x by using ln rule. ln of x is here. ln of x is crossed out. Final answer is 5. This is the whole idea for solving this problem like this. Okay, the next one. We think about indeterminate products. Here, limit of f of x times g of x. So here, what's that? You have to cross out just 1. Limit exists. Type is 0 times infinity, is right? The x value approaching infinity, the 1 of x is going to 0. X is going to infinity. Exactly 0 times infinity form. Second one, x is crossed out. Limit of x as x value approaching infinity is infinity. Limit does not exist. Type 0 times infinity. What's that? The limit may or may not exist in type 0 times infinity. So we call indeterminate form of type 0 times infinity. 0 times infinity. All right? This is called indeterminate form. How can you solve indeterminate product? How can you solve? So this is the idea. You can change fraction form. Limit f of x over 1 over g of x. Next, use L'Hopital's rule. Or f of x is going to denominator, use L'Hopital's rule. This is the whole idea for solving this problem. Does it make sense? Here. This is like 0 times infinity form. What happens? F of x is going to 0. Was it like 1 over g of x? G of x is going to infinity. This is going to 0. So 0 over 0 form. You have to use L'Hopital's rule. The same. 0 times infinity. So g of x is going to infinity. What is 1 over f of x? 1 over f of x is going to 1 over 0. 1 over 0 is going to infinity. Right? So infinity over infinity form. We can use L'Hopital's rule. This is like a whole idea. You can change it to the fraction and use L'Hopital's rule. Here. So let me see. This is like 2 possibility. The before you can plug 0 into here. X value approaches 0. What is ln of x? ln of x is going to minus infinity. So exactly 0 times infinity. 0 times infinity indeterminate form. How can solve? We have 2 possibilities. So what does it mean? X is going to top, ln x is going to bottom, 1 over ln of x. You can change the fraction. Or ln of x is top, x is going to denominator, 1 over x by using reciprocal. I can try first one. Limit x over 1 over ln of x as x value approaches 0 from the right. We can use L'Hopital's rule. The x prime, I can calculate the 1 over ln of x prime together. You can change ln of x to the minus 1 prime. You can use power rule. Minus 1 is down, minus 1 times ln of x to the power minus 1 times inner function ln of x prime. ln of x prime is 1 over x. You can change negative exponent minus 2 to positive exponent ln of x squared. So we can going back to previous example. X prime is 1 over ln of x prime is minus 1 over x times ln of x squared. So simplify minus x ln x squared. What happens? Original one is this form. Simplified form is more complicated. Like more complicated. This case is not good. So we can use the second possibility. You can use L'Hopital's rule, ln of x prime over 1 over x prime. So ln of x prime is 1 over x. 1 over x prime is minus 1 over x squared. The change multiplication. X is crossed out, just minus x going to 0. So that's it. This is the idea. So we have ln function and polynomial form. We have 0 times infinity form. What's like the best way? In this case, always change it like this. ln function is top is better. The x is going to denominator by using reciprocal. This is like a whole idea. You always choose this case. ln of x is top. The polynomial is going to bottom. This is like better for solving this problem. Indeterminate differences. F of x minus g of x form. So x minus x as x value approaches infinity. So what's that? Infinity minus infinity, but x is cancelled, just 0, right? Just x is cancelled. 0. The limit exists. X squared minus x. What is the answer? What do you think? What is the answer of this question? So what is the answer? So do you have any idea? Limit x squared minus x. What is the answer? Do you know? What is the limit of x squared minus x? Infinity, infinity. Right. You can factor out x. So what happens? This x value approaches positive infinity. X minus 1 approaches also positive infinity. Infinity times infinity is infinity. That's it. Limit does not exist. So what does it mean? The limit may or may not exist in type infinity minus infinity. Is right? So this case is, what's that? You plug infinity into x here, infinity minus infinity. You plug infinity into here and here, we have infinity minus infinity. We have the same form, infinity minus infinity, but sometimes limit exists, sometimes limit does not exist. So we call indeterminate form. How can you find? Try to convert the difference into a quotient, for instance, by using a common denominator, rationalization, factoring out a common factor, like this. So next, so you have to use L'Hopital, right? We have this kind of form, use L'Hopital. Here, 5-2 from the left, so what happens? Secant function approaches positive infinity. Tangent function is positive infinity. Exactly, infinity minus infinity. Was it like the best way for solving this problem? I want to use one identity. Do you know identity of a secant function? Was it like one identity of a secant? Do you know secant function? What's the identity of a secant? Do you know? What is the identity of a secant function? No, yeah, square root, yeah, you're right, yes. But I want to use only cosine sine function. Was it like identity of a secant function just using the cosine and sine? Yeah, 1 over cosine. Was it tangent? Just use cosine and sine. Was it like identity of tangent? Identity of tangent is sine of cosine. So we can change it like this. So what happens? Cosine of x is one common factor. We can combine 1 minus sine x. You plug pi over 2 into x. What happens? 1 minus sine pi over 2. Cosine pi over 2. So what's that? 1 minus 1 over 0 is 0 over 0 form. So how can you solve? You have to use L'Hopital rule. This is like idea. L'Hopital rule. Sine prime is cosine. Cosine prime is negative sine. So next, you plug pi over 2 into top one and bottom one. Cosine of pi over 2 is 0. Sine of pi over 2 is like 1. 0 over 1 is just 0. That's it. This is the answer. So last case, indeterminate power form. So what is the indeterminate form of f of x to the g of x? The one idea is you can take ln. Ln f of x, g of x. You can change it to the product. So we have one determinate form is infinity times 0. So in this case, g of x is infinity. G of x is going to infinity. The ln of f of x approaches 0. What happens? F of x. What's that? What's f of x? You can use graphic. Here, you can draw ln function. This is ln function of f of x. X-axis is log of f of x. So what happens? ln of f of x approaches 0. ln of f of x approaches 0. So here, what is this intercept? 1. So going to 1, like this. Next, 0 times minus infinity form. So here, g of x is going to 0. So ln f of x going to minus infinity. What happens to f of x? We can use same graph. ln of f of x. This is f of x. ln of f of x approaches minus infinity here. Minus infinity. What happens f of x approaches to 0. So we have this one. Next one, 0 times infinity, same. g of x going to 0. ln of f of x going to positive infinity, so we can use same graph, ln of f of x, this is like f of x. ln of f of x approaches positive infinity. This is approaches positive infinity. What happens to f of x? F of x going to positive infinity. So we have 3 types. What's that? You can change it from here. What is f of x to the g of x form, power form? The first one, 1 to infinity. Second one, 0 to power 0. Third one, infinity to the 0. We have 3 types of indeterminate forms. So 1 to infinity, 0 to 0, infinity to 0. We have 3 types of indeterminate form. The next one, how can you find limit of f of x to g of x? Indeterminate form. Step 1, take ln like this. The g of x is down, g of x times ln of f of x. Step 2, take limit as x value approaches a. Take limit. So how can you calculate this one? You have to use this idea. ln function top, g of x is going to bottom on by using reciprocal. You can use L'Hopital. Fine answer. This is not a final. So this is answer of ln of f of x, g of x. How can you eliminate ln? How can you eliminate ln? How can you eliminate ln? Do you know? The original problem like this one. How can you eliminate? Yes, take E, you're right. Take E, automatically E and ln is cancelled. Limit of f of x to g of x is E to L. You're right. So we try to solve this problem together. Step 1. Take ln. X is down. X times ln of 1 plus 3 of x. Step 2. Take limit. X value approaches positive infinity. So ln function is top. X is going to denominator by using reciprocal. Next, you can change this one to the x plus 3 of x form. Change it to the difference. Next, take derivative. So we have top one is x plus 3 prime over x plus 3 is 1 of x plus 3. ln of x prime is 1 of x. 1 of x prime is minus 1 of x squared. And combine, is right? You can combine. You can multiply x. You can multiply x plus 3. So like this, we have it. Simplify. The x is cancelled. The negative 3 over x squared plus 3x is numerator. The numerator is here. So you can change it to the multiplication by using reciprocal. So we have change like this one. Change positive 3x squared over x squared plus 3x. How can you calculate? You have to use relative rate of growth. X squared and the 3x compare. 3x is slow one, ignore. Just 3x squared over x squared. X squared is crossed out, answer is 3. It's not a final. Step 3, take E. Answer is EQ. Okay, this is the whole idea. So I want to give one easy formula. For solving this problem. We have this formula. X value approach is positive infinity, 1 plus a over x to the power bx. Answer is always e to the a times b. This is the idea. The one example is limit x value approach is positive infinity, 1 minus 2 over x to the power 3x. What is the answer? What is the answer? E to the 6 is right. E to the 6 is right. E to the 6, what do you think? E to the negative 6 is right. E to the negative 6. Answer is e to the negative 6 because you can change limit x value approaching infinity, 1 plus negative 2 over x to the power 3x. So what's that? This is e to the a is negative 2 times 3 is e to the negative 6. This is answer. This is answer for this problem. It's good. So this is like section 6.8. Next, so we think about section 7.8. Was it like 7.8? The improper integers. Here, this is our line. The first, I'm going to talk about definition of an improper integral. Second one, I can talk about two types of improper integrals. Third one, I can show how we can solve an improper integral. What is an improper integral? We can use fundamental theorem of calculus part 2. Function f is continuous on interval ab. The integral from a to b, f of x dx is capital F of b minus capital F of a. What's like capital F? Capital F is any antiderivative of small f. So that is a function such that capital F prime equals small f. So when do you use a fundamental theorem of calculus? The important thing is here. So what's like the important assumption here? Function is continuous. Interval is finite. Right? So we have these two conditions. We can use improper integral. So let me see. Was it like the proper integral? Was it like improper integral? To violate one assumption. The first case, the interval is not a finite. So like infinite. A is going to negative infinity, b equals positive infinity. So we call improper integral. Second case, function f is discontinuous at a, b, or c, where c is between a and b. This integral is improper integral. We have second type, discontinuous integrals. We have two types of improper integral. How can we solve these improper integrals? We think about this one. So we think about type 1 infinite intervals. So suppose that integral from a to t, f of x dx exists for every number t is greater than or equal to a. So how can you calculate? So we can use limit. Limit t value approaching infinity, integral from a to t f of x dx. This makes sense? This makes sense. Here, this is like exact thing. Was it like exact meaning of this one? The area under the curve from a to infinity, is right? So how can you calculate? So I want to cut t, find this area. So like this, take limit. What does it mean? T is going to positive infinity. What happens? You have to add more areas. Add more areas. So this is like exact meaning. So like this. So we have two concepts. Improper integral from a to infinity f of x dx is a conversion. So if the limit exists. Improper integral is diversion if the limit does not exist. The conversion, diversion. We have two concepts. Similarly, suppose that integral from t to b f of x dx exists. For every number, t is less than or equal to b. What's integral from minus infinity to b f of x dx? Very similar. Only difference is limit t value approaches minus infinity, integral from t to b f of x dx. This is like idea. So what's that? This meaning is the all areas, right? From minus infinity to b. What's that? You can cut t, find this area. First, next, you have to move t to the negative infinity. What does it mean? You add more, you add more, add more, add more. So it's going to exact meaning of limit, exactly improper. So same. Conversion, if the limit exists. Diversion, limit does not exist. It's like infinite intervals. So third case, integral from minus infinity to infinity, f of x dx. You can just split two improper integral, integral from minus infinity to a f of x dx, integral from a to infinity f of x dx. What's it like a? A is any real number. So what's it like a best choice of a? The best choice. Best choice of A is usually 0 is better. The simple number. You can choose 0. So conversion, the both conversion. Diversion, either one is diversion. So what does it mean? So this one looks like this one. So this one is diversion. This one is conversion. What is the answer? Improper integral is diversion. Here, the first one is conversion. Second one is diversion. What is the answer? Diversion. First one is diversion. Second one is diversion. Answer is diversion. Last one, first one is conversion. Second one is conversion. What is the answer? Conversion. It's like this exact meaning of conversion of diversion of a third case. So I want to give example. How can you solve? So this is like idea. You can find this area under the curve from 1 to infinity. How can you calculate? You can use definition. Limit integral from 1 to t, 1 of x dx as t value approaches positive infinity. You can use it. So take integral, 1 of x is ln of absolute value of x from 1 to t. You plug t and 1. What is ln of 1? What's ln of 1? ln of 1 is, yes, p said this is 0. T value approaching infinity, what happens? ln of t. What is the answer? So this one is limit ln of t value approaches infinity. The t value approaches infinity, ln of t approaches positive infinity. Answer is positive infinity. So what does it mean? Divergent. The limit does not exist. The divergent. This is the idea. Second one. Was integral 1 to infinity 1 over x to the power p dx. Case 1, p equals 1 from the previous one, right? P equals 1, exactly the previous example. Oh, this is a good question. Here, you can calculate this improper integral by using concept of limit. So improper integral, one example, improper integral, we can calculate improper integral. This is like a finite number. You can get the finite number. What is the answer? Improper integral is convergent. You can calculate improper integral. Improper integral is infinity minus infinity or the oscillating, something like that. What does it mean? Improper integral is divergent. And this is like exact meaning of a convergent or divergent of improper integral. Improper integral is finite number, convergent. Improper integral is infinity minus infinity, oscillating, divergent. This is like exact meaning. Does it make sense? Okay. Okay, good. The next one. The case 1, p equals 1, we already have it, the divergence from the previous example. Case 2, p is not equal to 1. How can you calculate? You can change it to the limit and definite integral. T value approaches infinity, integral from 1 to t, x to the power minus p dx. You can use power rule. X to the minus p plus 1 over the negative p plus 1 from 1 to t. You plug t and 1, you can factor out 1 over 1 minus p. We have this one, is it right? So because this is same to, you take out constant part, x to the negative p plus 1 to 1t. You can change one more to 1 over, this is 1 minus p. So do you know, change it to next way? This is exactly same to 1 over x to the negative minus p plus 1, change it like this. So we have 1 over x to the p minus 1. So we have it, right? 1 over x to the p minus 1 plug 1 to t. You plug t into x, we have it. You plug 1 into x, 1 here. So we have it. It's like idea. So we have two cases. First one, p is greater than 1. So what's that? The p minus 1 is positive. What happens? T value approaches infinity. So what's that? What is t value approaches infinity? What is t to the p minus 1? What is the answer? T value approaches infinity. What happens? T to the p minus 1. Do you know? Answer of this question? Infinity, is it right? So one example here, p minus 1 is greater than 0. I want to give one example, t square. The t value approaches infinity, t square approaches, positive infinity. So t to the infinity is like, so positive infinity. So we have infinity. What's the flip? 1 over t to the p minus 1 is going to 0 because bottom is going to positive infinity. This whole thing is going to 0. So we can apply this one. What happens? This is going to 0. So we have only 1 over 1 minus p times minus 1. We have 1 over p minus 1. Just conversion. Second one, p is less than 1. 1 minus p is greater than 0. What happens? T is approaching infinity. 1 over t to the p minus 1 is exactly t to the 1 minus p. The 1 minus p is positive number. One example is like t squared. T value approaching infinity, t squared approaches positive infinity. So what happens? This is going to what? Positive infinity. The infinity minus 1 is infinity. 1 over 1 minus p times infinity is infinity. Answer is divergent. Now I'm going to combine this whole result. So we have one good result. Integral from 1 to infinity, 1 over x to the p dx is convergent. If p is greater than 1, divergent if p is less than or equal to 1. So we have one good result. So one example. What is the answer? This is convergent or divergent? What is the answer? Convergent or divergent? What do you think? Divergent? Yes, because this is the same to 1 to infinity, changes the 1 to the x to the 1/2. Was it like a 1/2? This is like p. P value is less than 1. Exactly this case, divergent. So that's it. This is the idea. Just use one good formula for solving this problem. The next example. So minus infinity to infinity was like a best way. You have to split two integrals. Split two integrals. So you can change it to the limit values. The first one, integral from t to 0, 1 over 1 plus x squared dx, take limit, t value approaches minus infinity. Second one, integral from 0 to t, 1 over 1 plus x squared dx, take limit, t value approaches positive infinity. The next to find antiderivative. integral 1 over 1 plus x squared is inverse tangent, plug 0 and t. So is right. So we have this one. What is inverse tangent of 0? What is inverse tangent of 0? Do you know inverse tangent of 0? Yeah, 0, the pi by 2. What do you think? 0 or pi by 2? Inverse tangent of 0 is 0 because inverse tangent of 0 is, we don't know, angle theta. Use definition. 0 equals tangent theta. Theta equals angle 0. So this is going to the 0. So one more. T value approaching minus infinity. What happens? Inverse tangent of t. So what is the answer? Minus pi by 2. Is right? Minus pi by 2. Yes, we can use graphic. What is inverse tangent of t? Here, top one is pi by 2, bottom one, near pi by 2. Graph is like this. So this function is inverse tangent of t. T value approaches minus infinity. The inverse tangent function approaches minus pi by 2. So first one is keep negative sign, negative minus pi by 2 plus t-value approach infinity, inverse tangent of t is, what's inverse tangent of t? The t-value approach infinity, so what happens inverse tangent of t? He said pi by 2, Kylie said pi by 2, yeah, this is pi by 2. So t-value approach is positive infinity, this function approach is pi over 2. You simplify pi over 2 plus pi over 2. Answer is the pi. That's it. This is the whole idea for solving this problem. Like this. Next one, we think about discontinuous integrons. How to evaluate the improper integral of type 2? Suppose that function f is discontinuous at a. So what does it mean? The graph is, how can you calculate? So I'm going to give an example here. So we have is B here. Graph is like this. We have infinite discontinuity from A to B. How can you calculate? This is the idea. You have to cut here like T. Find this area first. This area first. This area is, what's that? This area is integral from A to T f of x dx. How can you add the remaining part? Idea is very simple. The t-value approach is b from the left. Take limit. T-value approach is b from the left. That's it. This is the whole idea for solving this improper integral. So we have like this. This is a graph. So same is a conversion. If the limit exists, the divergent limit does not exist. Suppose f is discontinuous at a, we can use opposite way, right? Like this. Here we have a. The b. How can you find this whole area under the curve from a to b? So we can calculate integral from a to b f of x dx. How can you calculate? You have to cut. Find this area first. So this area is integral from t to b f of x dx. The next, the t-value approach is a, we have to cover remaining area. So limit t-value approach is a from the right. That's it. This is the whole idea. Like this. So improper integral conversion, if the limit exists, improper integral is divergent if the limit does not exist. This is the idea for solving second problem. The third one, suppose that f is discontinuous at c, c is between a and b. How can you do that? You can split two improper integral from a to c, integral from c to b. So this is like an idea. You can split two improper integral. So convergent, both are convergent. Divergent, either one is divergent, the same things. So here, this is convergent, this is also convergent. So improper integral is convergent. This is divergent, this is convergent. The answer is divergent. This is like convergent, this is divergent, answer is divergent. The both of them is divergent. First one is divergent, second is divergent, answer is divergent. This is like exact meaning of convergence and divergence of this case. This is like example. Let me see. This is improper integral, is it right? This is improper integral. My point is the given function 1 over the square root of x minus 1 is discontinuous, is it right? Discontinuous. This function is discontinuous. Yes. P said yes. The y. Add 1? Yes. You plug 1 into here, what happens? The square root of 1 minus 1 is, 1 over 0, like a vertical asymptote, right? So this is undefined. Undefined. So what does it mean? 1 over square root of x minus 1 is discontinuous. Discontinuous at left point 1. That is continuous. So you can use substitution rule. The u equals x minus 1. The du is x minus 1 prime is only dx. This is ideal. You can change it to the limit things, is right? Here. This is 1 and 4. So we have discontinuous at 1. Discontinuous at 1. You can choose a value t. T value approaches 1 from the right. You can change it like this. So next, you have to use u substitution. You plug u value into here. The tx is tu into here. So we have it. Next, you have to use power rule. Change it here. What is g of t? You plug t into here. G of t is t minus 1. What's 4? Plug 4 into here. 4 minus 1 is like 3. The next, power rule. Limit 1 over negative 1 over 2 plus 1 u to the minus 1 over 2 plus 1 from t minus 1 to 3. You plug to simplify 1 over 1 over 2 is 2, u to the 1 half, exactly 2 times root u. You plug 3 and the root t minus 1. So what happens? You plug 1 into here. 1 minus 1 is going to 0. So we have 2 root 3. So what does it mean? This improper integral is convergent. Convergent to 2 root 3. This is like answer. The last one, a comparison test for improper integrals. What's that? Comparison theorem, suppose that function f and g are continuous function with g of x is between 0 and f of x. For x is greater than y equal to a. The first function f, the integral from a to infinity, f of x dx is convergent. What's the conclusion? Integral g of x dx is also convergent. Second one, if integral from a to infinity, g of x dx is divergent, then integral from a to infinity, f of x dx is also divergent. So why this is true? Like this here. The case 1, A, we have this inequality. You can take integral from a to infinity dx, from a to infinity dx, from a to infinity dx. Was it like a condition for a? This one is convergent. What does it mean? The integral f of x is finite number. So integral g of x is between this integral from a to infinity 0 is also 0. Finite number and finite number. This is also finite number. So convergent. So was it like second case? Same idea. 0 So like this is like B. How can you do that? Take integral from A to infinity dx. Integral from A to infinity dx. Take integral from A to infinity dx. What's the assumption? Integral g of x is divergent. What does it mean? This is like infinity. So integral f of x dx is greater than or equal to infinity. We have only one possible answer, infinity. This is also divergent. That's it. This is the whole idea for solving the comparison test for improper integral. I want to give the last example. Show that integral from 0 to infinity e to the minus x squared. So do you know what is this one? Do you know? So what is integral e to the minus x squared dx? Do you know answer? Do you know the answer of this question? Do you know how can you solve? Do you know? Impossible. What is integral e to the minus x dx? Do you know this one? Integral e to the minus x dx? Do you know answer? We have to use this rule. Do you know this one? Integral e to the kx dx is 1 over k e to the kx plus, we can use a formula. So this is 1 over minus 1 e to the minus x plus c is minus e to the minus x plus c. This is idea. So what does it mean? So we cannot calculate this one. How can you do that? You can compare this one with simple one. This is the whole idea by using comparison testing. So you can draw the graph here. E to the minus x squared is red one. E to the minus x is blue one. So what happens? The e to the minus x blue one is greater than or equal the red one. For x is greater than or equal to 1. So we have it. So next, you can take integral of simple one. You can change it to the limit t value approaching infinity, integral from 1 to t e to the minus x dx. You can find antiderivative minus e to the minus x, plug, change it to the positive exponent, minus 1 over e to the x, plug t and 1. So we have it. T value approaching infinity, what happens? The e to the t approaches positive infinity, minus 1 over infinity is going to 0. The 1 over e. So next, we know this result. Integral 1 to infinity, e to the minus x dx is convergent. So what happens? You have to use this inequality. When you take integral from both sides, we have it from 1 to infinity. So what happens? This is finite number, like a convergent. The small one is also finite number, convergent. So we have like this. This is not final. The original problem is integral from 0 to infinity. So you have to split two integrals. What happens? Integral from 0 to 1, e to the minus x squared is here. 0 to 1, e to the minus x squared is the area under the curve. This one. This is always finite number. This one is like convergent. What does it mean? Second one is also finite number. So this whole thing is finite. So what does it mean? Improper integral is convergent. That's it. This is the whole idea for solving the last problem. Okay, so this is all for today lecture. So do you have any question in section 6.8, 7.8? Today lecture is a little bit faster, I know. But so this is my best for explaining the two sections. So do you have any more question? So do you have any more question? So if you don't have more question, yeah, question. So just to, if you don't have any question, you can leave. So if you have any question, to write something and explain. All of them. I just waiting. Okay, you're welcome, a lot of guys. Yeah.